been taking 2 points, finding slope, but one of those points has always been your y-intercept. True? Okay, well, what if I need you to write the equation of a line and you have 2 points, but you don't have the y-intercept, okay? We need to be able to write the equation of a line with or without our y-intercept. We're still going to write it as y equals mx plus b, but there are going to be times where we don't know the plus b, okay? There's a couple different ways I'm going to show you how to do that. Okay, but for today, we're going to focus on what's called point slope form. Okay. Before I actually fill in this box right here, don't draw a box. We're going to come back and fill that in. Okay. I want to talk about how we find slope. Okay. How do we find slope? Okay, so what I'm going to do is I'm going to say, okay, I have a coordinate, but I don't necessarily know what the second one is. Okay, so what I'm going to do is I'm going to write it like this. I'm going to write our slope is y minus y1 and x minus x1, okay, just for right now. Okay. Now, how would I get rid of having a fraction on the right side?
You would need to take the numbers minus the numbers. You would take y2 minus y1.
Well, I want y2 minus y1 to stay. What would I need to do with this number? How do I get it so it's not in the denominator anymore, Em? With what operation? Phone a friend, Connor? Multiplication. Okay. So let's see what that would look like. If I take my x minus x1 and I multiply it over to be with the slope, and now I have y minus y1 all by itself. You guys. This is what we call point slope form. So in this blue box, I want you to come over here. We're going to write y minus y1 equals m times the quantity, that means our parentheses, x minus x1. Okay, what's the name of this? What is it called? Do you know why it's called point slope form? Because in order to use it, we need a point and we need slope. If we have slope, we can plug it in here for m. If we have a point, we can plug here for x1, y1. That is it. Point slope form, which is just the rearrangement of how we calculate slope. Okay. Let's talk about how we would use it. Okay. I'm going to come down here. I'm going to draw a picture. I want you to draw with me. Okay, so I want you to draw that line. In order to use point slope form, all we need is a point and a slope. Okay? So, what's our point? How about 2, -2, right? Okay. What is our slope?
Our slope is
Rise how many? And run how many? So our slope is 3/2. This is what we're going to do. Y minus y1 equals m times x minus x1. I want everyone to write that right now. That is point slope form. I want you to write it so when you go back to look at your notes, you know why you put the numbers where. Okay? So here's the deal. When we use point slope form, we're trying to write the equation of a line, so we need the y, we need the x. So this guy is going to stay y, and this guy is going to stay x. Okay? M is our slope. So I am going to put 3/2 in for m. Okay? Okay? I'm then going to take my point. I'm plugging in for the x1, y1. So here we want x minus 2. And here we want y minus -2. But y minus -2 is the same as, okay. Now, we recognize our linear equations when they are in slope-intercept form. So what are we going to need to do to turn this into y equals mx plus b? There's 2 steps we got to do. What's the first one? What are we doing?
distribute.
We're going to have to distribute. So let's take that slope, 3/2 times x minus, what's 3/2 times 2? Which is 3. Okay. Now, if I want to if I want this to look like y equals mx plus b, what's our second step? Take that 2 and let's subtract it over. So what we have is y equals 3/2 x minus 5. Ta-da. Okay, do you have a question? Okay, turn the page. I want you and your elbow partner to work together on number 1.
So basically, x
We put this y is a -2. Would that be?
So-
So make it y plus 2.
Well, this is the x, and that's the y.
This is x.
Yeah. X comma y. Yeah. Okay, something that is going to be a little bit tricky sometimes, especially when some of us like to be very swift with our math pace. Okay. We know that our slope is -3, but what I need you to be careful about, and what I'm seeing already happen, and I knew this was going to happen, this is x, this is y, right? So this is y minus 1, and this is x minus -2. So make sure you get x plugged in with x and y plugged in with y, because in the formula y comes before x, and sometimes our brain doesn't always process that, okay? So did you get y equals -3x minus 5? I'm really worried about them. We distribute and then add over that 1. What? Right. Fair. The question did say write an equation in point slope form. And Mrs. Holman was thinking, I want you to get it into slope intercept form. But you didn't read my mind. It's okay if you didn't read my mind. I do not expect that. Okay. Now, in number 7, I am asking for the slope intercept form of the line. Okay. Now, let's just talk about doing number 7 and ignoring the fact that we can see the y-intercept. Okay, is that cool? Can we just ignore that fact? What is our slope? Our slope is 2. Now, if, let's say you couldn't see this right here, okay? And you're like, okay, well, I'll just use my point slope form. Obviously, that's not the most efficient, but it's cool. We know that our slope is 2. Which coordinate do we pick?
We picked the Y. Oh, wait, no, we picked the B. Oh,
Does it matter? It does not. It does not matter. So this is what I want you to do. If you are on the yellow, green, or teal table, I want you to choose this one. So yellow, green, and teal table. You're picking that one. And then if you are in the red, purple, or blue, I want you to use that point and find me my line in y equals mx plus b. All right. Somebody from the purple table, what'd you get? Is that what you got? Is that what you got? Y equals 2x minus 4? Oh my gosh, it doesn't matter. As long as the point is on the line. Now, if I had the choice, in this particular instance, I would probably choose the 3, 2 point. Why do you think that that would be a choice that I would make over the other one? Because neither of the numbers are negative, and I think that would just be nice to plug in. But does it matter? No, it doesn't matter. Doesn't matter at all. Okay? So, next page. I want you to look at 13. I want to know what the linear function is I don't know what to do. Okay, so I'm looking over somebody's shoulder and they wrote this, -3, -1, and -2, 4. Okay, if that helps you, write it. Okay, if I need to write the equation of a line, what do you suppose is something that we need? Somebody's trying to say it, but I can't hear you. Oh, say a letter. Slope. We're going to need the slope. No matter what line we're talking about, if we're going to write its equation, we got to have the slope. Go and find me slope. What's our slope? 5 over 1, right? Which is 5. Okay. I took 4 minus -1 and -2 minus -3. Okay. And I got 5 over 1. If you did the reverse of that, you got -5 over -1, which gets you still a positive 5. Okay. Again, if we are going to use point slope form, does it matter which point we choose to plug in? It does not. So we can plug 5 in for our slope. And we can plug in, does anyone have a preference? -2, 4. So x minus -2 and y minus 4. So we get 5x plus 10 when we distribute. Yes? So the equation of our line is 5x plus 14. Aren't you glad you don't have to graph that?
Technically the number that's like on the right side of the equal sign is like a y value.
Ah, so yes, let's talk about this. Once we get it to y equals mx plus b, we know that this is our slope and this is our plus b, so this is our y-intercept. So if we wanted to graph that, we start at 14, we go up 5 over 1, up 5 over 1.
Like the f of x equals -1. That's our, is that our y value?
Yep. This is x, this is y. Okay. So how about this? How about you try number 18. You try number 18. I like that I'm hearing some people comparing answers. All right, Emily, what'd you get for your slope?
Oh, I got -1. I got 1.
So if we take 6 minus 5 and then 2 minus 3, I think -1 is correct. Joey, do you see that? Okay. So then we know our slope is -1. Eva, which point did you use?
I used 5 and 3.
You used 5 and 3. So x minus 5 and y minus 3. So y minus 3 equals -x plus 5. So when you add it over, you have -x plus 8. That matches your answer?
Yeah.
Oh, if you have -1x, that's totally cool. But the 1 is not necessary.
We put the wrong. We thought I accidentally swapped 3 with the 2.
Ah, okay. Yeah, we just got to be careful with that. Yep. All right. So let's come down here to number 21. Okay. And something that I really want to emphasize is what that slope means in context. So do you remember back in chapter 3 when we were looking for, is it linear, is it not linear? What was something that we were looking for, especially with the numbers? Connor? A constant rate of change. Now let's focus on, okay, what is that constant rate of change referring to?
Like x plus 1 plus 1.
Right. So if we're talking about a line, what is our constant rate of change referring to? What feature of the line, Em? The slope. Okay, so anytime we have a rate of change, that is signifying our slope. Okay? Craig is driving at a constant speed of 60 miles per hour.
So 6n. 60n. Well, it says d, but I prefer 60n because it says 60 miles.
Okay. Well, it's saying 60 miles per hour. Okay? They just gave us a rate of change, didn't they? Ah. So if we can remember that slope is the same thing as our constant rate of change, then we can look at a rate of change like 60 miles per hour and be able to say, that's our slope. Okay. Now, after 3 hours, his odometer reads 265 miles. What does the odometer read after 7? So basically, after 3 hours, his odometer reads 265. That's giving us a coordinate. Write a linear function d that represents miles driven after h hours. This is what we're going to do. We're going to use x's and y's, and then we're going to go back and change them to d's and h's. Does that sound fair? Okay. So, hey, look. We have slope, and we have a point. If we have a point and we have slope, can we write the equation of a line? Yeah, let's do it. Okay. Y minus y1 equals slope times x minus x1. Okay, our slope we decided was our 60 miles per hour. Okay. And then our coordinate is 3 hours after 265 miles. Okay. H, our number of hours, is our independent variable, but our miles driven, that's dependent. It's depending on how long we drive to figure out how far we've gone. Okay, so now let's do the math. If we multiply that through what we have, 60x minus 180. And then if we add 265, help me out. 85, like that. Okay, now as promised, we need to change y to d because d represents the miles driven after h hours. Okay, so I just changed y to d, x to h. Now, how do we figure out what our odometer reads after 7 hours of driving? What can we do, Connor? Yeah, we can plug the 7 in for h. So here is our linear function, okay? Our odometer started at 85 miles. We're going 65 miles per hour. So now, after 7 hours, okay, we take 7 times 60, giving us, okay, in that time we've driven 420 miles, plus the 85 that we started with. Okay. Okay, so our slope is always going to be our rate of change. Okay, so looking at that problem, the speed is a rate. Okay, I knew that that was slope. Then y and x we have to figure out right here. A linear function d representing the miles driven after h hours. So we know that h is our independent variable, and then d is our dependent variable because the number of miles that we drive has to depend on how long we've driven, okay? So when we can pick out which one's independent, which one's dependent, we know which one's x, which one's y. Does that make sense? Okay.